Let's look at what's happening in this graph. For the first thing, we have car X, which has a velocity at the beginning, and that velocity stays constant the entire time. Car Y starts from rest and increases its velocity. But remember that the area underneath a velocity time graph is the displacement. So car X travels from 0 to 20 seconds and covers the area that's bound within this rectangle, whereas car Y only covers half as much displacement in 20 seconds because it's just this triangle. So if we look at the first question says, which of the following must be true at time equals 20 seconds? Well, if car Y only covered half of the displacement, then car Y must be behind car X. So the answer is A. Question 2 is asking us what's happening at 40 seconds. So in that point, they tell us that the area under both curves are equal. So that tells us that they're both in the same position. They're both in the same place at the same time, but they're not doing the same thing. If we go back and look at the graph, this car is moving much faster. Its velocity is higher. So what's it doing if they're in the same position but going faster? It must be passing car Y. So the areas are the same. So car Y is passing car X. So for this graph, they're looking for something that is traveling with position versus time, distance versus time, and also speed versus time. And they're saying it's accelerated uniformly from rest. So let's look at these 3 choices, or well, 5 choices actually. And if we look specifically at choice E, this is the answer, the position graph, the slope is getting steeper. So what does that mean the velocity is doing? It means the velocity is increasing. And if we look at this graph, the velocity time, or they said speed and time, the slope of this graph is constant. So what does that tell us? The acceleration is 0. And that the acceleration is constant, which means it's constantly speeding up. So the answer is E. This one's a little bit tricky because they made these answer choices so small. But basically what we have here is a velocity time graph, and we can see that the velocity is increasing, then constant, then decreasing. Well, we know that for a position graph, and we can look at choice D here, this initial part has a increasing slope. So that means the velocity is increasing. But then in the center section, the position is increasing at a constant rate, which tells us that the velocity here is constant. So that's why this is constant here. And then the slope starts to do this. It starts to decrease, which means the velocity is decreasing. So the answer is D. Okay, we have a velocity time graph here, and we can see that the velocity starts out with some initial value. It's constant, then the velocity decreases, it stops, then it increases in the negative direction, and then it's constant velocity at the end. So if we look at choice A, the first portion of this graph is straight. So that means the velocity is constant and positive. That agrees with this. Then the slope starts to decrease, which means the velocity decreases until the slope becomes 0, at which point it stops. Then the slope increases, which means that it's increasing in the negative direction, and then it becomes straight again at the end, but negative, which means the velocity is constant and negative. In this problem, we have a 2-dimensional ball that's launched through a parabolic trajectory, and the question that it's looking for is which graph represents the horizontal component of the velocity. Well, we went over this in the lesson part of this, and we know that there are no forces acting in the horizontal direction. So the F net horizontally is 0. So the horizontal acceleration is 0, and the velocity during the entire path is constant. So what does constant velocity look like? It is a constant positive velocity, so it's choice E. And then number 7, which graph represents the vertical component? Well, we know that the vertical component starts out with a large value that decreases to 0 and then increases on the down trip. So what's that going to look like on the graph? Well, the vertical component is going to start as positive and a large value. It decreases till it gets to the top, it stops, then it increases in the negative direction.